Hello everyone and welcome to my channel Coding Card. So today we will try to solve one very interesting problem. The problem name is find merge point of two list. So here the problem states that here we will be given two linked list and they will be merging at some point. So we have to find that merging point. And the constraint is the head of first link and head of the second list won't be null and they won't be equal. So we have to complete this function find merge node. And in this function we are provided two parameters head 1 and head 2. Means head node of both the linked list. So we have to find the merging point. For example, you can see here we are provided the linked list one as 1, 2, 3 and another linked list as 1, 2, 3 and they are merging at point 2. So we have to find the merging node and we have to print the data present in that node. So you can see here 2 is printed. So for example, you can see here the first linked list is 1, 2, 3 and null and the second list is 1, 3 null and they are merging at node 3. So they are printing the data part that is 3. So the very simple approach will be, suppose I am taking one example. Suppose I have a list 1 as suppose this is the first one is L1 and this is L2 and they are merging at this point. So the approach is we will first take two pointer, suppose P1 and P2, and we will iterate throughout this list L1 and L2 and we will check one condition. If P1 is equal to P2, then we will break the loop, else we will move forward, else we will simply move forward by one P1 equal to P1 dot next and P2 equal to P2 dot next. And suppose if here you can see here P1 is a small, if P1 reaches end, if P1 equal to none means if it reaches the end, we will simply assign the head node, corresponding head node, head 1. And if P2 equal to none, then we will simply assign the head 2 to this pointer. Quite simple logic. Now suppose initially we are here, P1 is here and P2 is here. Now you can see here P1 and P2 are not equal, so it will move forward, it will move forward. Again P1 and P2 are not equal, now it will move here and P2 will move here. Again they are not equal, again it will move forward and it will move forward. Now you can see here P1 reaches the end. When P1 reaches the end, we will simply assign the head pointer, means head 1 to P1. So P1 will be here again and P2 will be here. Again they are not equal, P1 will move forward and P2 will be here. Again you can see here P2 reaches the end. Now we will again assign the head pointer to P2. Now P1 reaches here, again P2 will move forward. You can see here again P1 reaches here, P2 will move on forward. Again P1 reaches the end, so again we will assign the head pointer. So P1 will be here and P2 will be here. Now again P1 is here, P2 is here. Again P1 reaches here, you can see here. Now at this point P1 and P2 are equal. So now here P1 and P2 are equal, then we'll simply break the loop and we'll simply print the P1 dot data or P2 dot data. We'll simply break here and return either P1 dot data or P2 dot data because the node is same for both. So now you can see here we have iterated 3 times for P1. So if I change the logic here, suppose I am changing here the logic. Suppose here Whenever P1 reaches the end, we are assigning the head pointer, means its corresponding head to the P1, means we are assigning head 1 to P1 and head 2 to P2 whenever they are reaching to the end. Now instead of head 1, if I assign, suppose if P1 reaches the end, so suppose for example P1 is here and P2 is here. First move, here, here, it reaches here, now P2 is here. Now suppose whenever P1 reaches the end, instead of assigning its own head, if I assign here P1 equal to head 2, then it will come here. Now P1 will be here. Now you can see here, but my P2 is here. P1 move one forward, P2 here. Now you can see here. Now P2 reaches the end. Now if I delete this head 2 and assign, if I interchange the head, if I assign head 1 to P2 and head 2 to P1, then what will happen? It will go here and P2 will move here. It will go here again, P2 here. Now at this point you can see here they will meet at each other. So you can see here previously we are iterating 3 times, but in this case while changing this condition we have met in only 2 time iteration. So this will be more efficient logic. We will simply interchange the head of, means we will simply, if P1 reaches the end we will simply assign the head 2 pointer, head 2 node in P1, and if P2 reaches the end we will simply assign head 1 to P2. So let us write the code. We will take first 2 pointer, P1 equal to head 1 and P2 equal to head 2, and we will simply iterate throughout the loop while 1, and we have a condition checking. If P1 equal to P2, then we will simply return, means break the loop, else we move forward. P1 equal to P1 dot next and P2 equal to P2 dot next. Now if P1 reaches the end, if P1 equal to none, P1 equal to none, then what we will do, we will simply assign the alternative head pointer. P1 will be assigned to head 2, and if P2 reaches the end, we will simply assign head 1, P2 equal to head 1, and at last when this condition is satisfied, when P1 equal to P2, it simply breaks and we will simply return either head 1 dot data or head 2 dot data, means P1 dot data or P2 dot data. Here I am returning P1 dot data. So let us run this code. So you can see here we are done with the sample test cases. So let me submit this code. So you can see here we are done with the hidden test cases. So congratulations. So this is quite interesting question. We have to find the merging points. So simple hack was we have to take 2 pointer P1 and P2, and we have to check whether P1 are equal to P2 or not. If they are not equal, we will simply interchange the head node, means P1 will equal to head 2 and P2 equal to head 1. And at a time will come when P1 and P2 will be equal, and we'll simply break the loop and we'll simply return the data part of the merging point. So if you like this video, please do give thumbs up and subscribe to my channel. Thank you for watching.